The global IPv6 addresses are public. So what are the other types that we have? As a reminder, we have loopback addresses to test the TCP/IP v6 protocol stack. So if you want to double check to see if everything's working locally on the device, ping ;1, and that tests your loopback. Unspecified, so if we don't have an IPv6 address yet and we do need to send out a packet, we can throw ;; in there. You'll also see that when you look at a routing table, if you see ;/0, well, that is a default route, because the default route is 0000000000000 with a prefix length of 0, right? So it just gets truncated to ;/0. But in a packet itself, if you see the source address is ;; it means that we don't have an IPv6 address yet, so we're just communicating using all zeros as our address. And in a routing table, if you see ;/0, then you're dealing with the default route at that point in time. A bunch of reserved addresses for IETF uses, and then we have some local addresses that we can utilize for local communication. So first and foremost, we have our link local address. Starts with FE80 ;/10. So what is the range for that? Well, if we have FE80 with a /10, that means the first 4 bits are going to remain the same. The next 4 bits are going to remain the same. So we're FE no matter what, because those aren't going to change. But the first 2 bits here have to remain the same. All right, so we got 4 bits, and then so 4 bits, and then 4 bits under the E. And then for the 8, there's a total of 4 bits there, but that's 12, and we only need 10. So what is 8 in binary? Let's figure that out. 8 in binary is going to be 1, 0, 0, 0. So it's going to be FE80 to start with. And 10 gives us this. So then in that, we could have zeros or ones there. So if these were all ones, what does that equal? So 1, so that's 8, 9, 10, 11. So 11 is what in hexadecimal? So 10 is a B. So FEB, and then what would be the highest value? BF would be the very last value we could have in there. So it would be a range from the first octet of FE80 all the way to FEBF would be the very last value that we could have in the very first field. All right. I think I said octet a couple minutes ago. I meant field. So in this particular case, we have our field starting from FE80 through FEBF. If you have the very first field at all within this range, then you're dealing with a link local address. So every single device will automatically generate its own link local address. And what you typically find, FE80 is pretty much what is going to show up on the majority of devices. So you're going to see FE80 and then ;; followed by the interface identifier, because everything else is 0 right here for the link local address. So essentially it's FE80:0:0:0 followed by the interface identification. So when every single device generates one of these link local addresses, it's for local link communication. Local link communication, meaning that we can utilize it for different services and features whereby we need to communicate inside of our local area network. So for example, when you have 2 routers that want to send with IPv6, so you have router 1 and you have router number 2 in this particular case. When router 1 wants to talk to router 2, dynamic routing protocols, or we want to forward traffic, well, since we're on the same local link here, we're going to use next hop IP addresses that are FE80 addresses, so link local addresses. We're not going to utilize global addresses or unique local addresses. Why? We're on the same link. I can reach you with that link local addresses. That link local address. So that's what we're going to utilize the majority of the time when we have to communicate internally for a lot of services and protocols inside of a local area network, the link local address. So even PCs are going to generate their own link local address, and they're going to communicate with their default gateway as well with the default gateway's link local address. Now we have our unique local addressing here, and the unique local addressing starts with FC00:7. So what's the range of that? We have FC00/7. So we're dealing with just the first 7 bits here. So we have 4 bits here, so that's going to stay as F. And then we have 4 bits here, so C is what? C is equal to 11. So 8, 0, 9, 10, 11. C is equal to 11. Sorry, C is equal to 12, not 11. A is 10, B is 11, C is 12. There we go. Makes more sense. All right, so we have here, what do we have? We have 8, 9, 10, 11, 12. All right, so there we go. So that's what C is in binary. So the first 7 bits, we have 8 bits or 4 bits here, 4, 5, 6, 7. So those can't change. So if I bring those down, this can be a 0 or a 1. So this is the starting range up here, which is C. So this is C. And the ending range would be what? D. So F, D, F, F could be the final value you find as the first field of a unique local address. So what are the unique local addresses for? They're like your IPv4 private IP addresses. So they're routable inside of our organization, but they're not routable out on the internet. So if you want to implement private IP addressing like you did with IPv4, then you're going to use unique local addressing. And as a result of that, if you want to get on the internet, you're going to have to use what? Network address translation for IPv6, which we're trying to avoid. So what you might consider doing is just use unique local addressing on those devices that you never, ever, ever want to have internet connectivity. For example, does your router interface really need internet connectivity? No, it doesn't. Does it? Not unless it's what? Sending packets to the internet. Right? I'm not talking about forwarding packets to the internet. I'm talking about communicating itself to the internet, meaning when I create a packet, I put my source address in it. Well, no. The routers are just going to be talking to each other inside of the organization and forwarding the global routes that they know about. Well, I don't need global addresses on my routers to learn global routes. I don't. So maybe we'll set up the routers inside the organization with unique local addressing so that way we never have to worry about them communicating to or from the internet. And then the end stations get global addresses so they can talk to and from the internet. So just different ways that we can set up our IPv6 environment to make it safe, make it secure, make the addressing much more efficient, and only rely on global addressing for global communication. And then if not, you don't need global communication, use your link local address. And remember, everybody's going to get a link local address as well. So link local address, unique local address, and global addressing, the big 3 that we could utilize or will be utilizing for our IPv6 communication.